How is it going, ladies and gentlemen? This is the Wolf Around, and it's great to see you here. This is an important video in the Vulkan C++ game engine development series, because the libraries we'll compile here are essential for the series and will shape our project configuration. I'll provide the most straightforward and concise explanation. Subscribe to the channel, join the pack, you are always welcome here. Without further ado, let's get started. Developing a game engine is a serious and challenging task. Being able to compile the libraries you'll use in your project is crucial for having full control during development. I could download pre-compiled libraries from vulkan.lunarg.com, but doing so would make troubleshooting harder when encountering unexpected errors, since I didn't inspect the relationships between the Vulkan libraries I'll be using. As a software engineer, I believe it's essential to understand exactly what the tools I'm using are doing. That's why I decided to prepare this video. I'll explain the entire compilation process in a straightforward and concise manner. I've written a batch script to automate this process and make it easier to explain. First of all, Visual Studio or build tools for Visual Studio must already be installed on your system. Installing one of these will also install CMake and Ninja, which is used in this script. Additionally, Git must be installed to download the Vulkan library's source code. The script will verify if Visual Studio or the build tools for Visual Studio is installed and set up the necessary environment variables for compiling C++ code. Check if Git is installed. Confirm whether the Vulkan library's source code has already been downloaded. The script will download missing ones. Ask which CMake generator you want to use, Ninja or Visual Studio. Ask whether you want to compile the Vulkan libraries as a release or debug build. Optimize the compilation process. The script detects your computer's maximum thread count and uses 2 fewer threads for compilation. Clean the previous configuration. This is required when you need to run the script consecutively. Configure the CMake arguments. I've enabled the necessary options and disabled unnecessary ones in all configurations, such as examples and tests. After each configuration, the script will begin the compilation process. Some configurations are depend on others. GLSlang depends on SpearV tools. ShaderC depends on both GLSlang and SpearV tools. Vulkan utility libraries depends on Vulkan Loader. Vulkan tools depends on Vulkan utility libraries and Vulkan Loader. Finally, Vulkan validation layers depends on Vulkan utility libraries, Vulkan Loader, and SpearV tools. Understanding these relationships will give you full control over what you are using. Let's open a terminal in the same directory as the script and run it. I'll choose Ninja as the CMake generator. I'll compile it as release. Compilation is complete. I won't perform a compilation for debug builds. However, you can do it if you need. Now, let's inspect the compilation output directory. Vulkan validation layers. We'll use these to identify potential problems and set up a proper Vulkan initialization. Vulkan tools. These are the tools we'll potentially use in this series. GLSLC. I'll use it to compile our shader codes. Vulkan Loader. This manages your GPU vendor's Vulkan implementation. Make sure your GPU drivers are correctly installed. I'm a software engineer specializing in computer graphics, game development, GPU hardware acceleration, AI inference, and cross-platform C++ development. I look forward to sharing more insights with you. Please like, subscribe, and leave a comment. I'll see you in the next one.